So we've talked about a regular mean, and by that I mean you just add up all the data values in your data set and then divide by how many data values there are. Last lesson we talked about the trend mean, where you take off perhaps high or outliers or highest and lowest scores, so you can address outliers and get a better idea of the measure of center using the mean. And now we're going to do something called the weighted mean. So, for example, you don't have to write this down. Rather than the examples I put on the page there. Grade 12 pre-calc. How is your mark calculated? Well, in the course that I teach, okay, you write a series of tests. I average them all out and you get a certain mark. That is worth 80% of your final mark. The final exam, the convention exam, is worth 20% of your final mark. So how did you do? Let's say that you go into the exam with 85%. Okay? And you end up getting 70% on the final exam. What's your total? What's your final mark? Well, we do something called the weighted mean. So what we would do is we would say, okay, this 85% is worth 80% of your final mark. So this 85% is worth 80%. So we want to figure out how many marks is that. So 80% of 85 is 85 times 0.8. So what that means is that works out to a 68. So that means out of 80 marks here for your final mark, this means you got 68 of it. Okay, so right now you have 68 marks. On the final exam, you got 70, but that's only worth 20%. So we want to find how much is 20% of 70. And that's going to work out to be 14. That means out of 20 marks that your final exam would be worth, you got 14. So you add those together to get your final mark. Now we would have to divide by the sum of the weights in decimal form, but that's going to be 1, so I don't have to do that. So when you add these two together, 68 and 14, you get a final mark of 82%. Okay? That's how you would calculate your final mark. And I know students like to play the game sometimes of, okay, I got an 85%, what do I need on the final exam to get this mark? What do I need on the final exam to get this mark? Okay? Well, this is how you calculate it. Okay? So doing this is called the weighted mean. We're adding all the percentages together, but each category has a different weight. The tests are worth more than the final exam. So that, like I said, is something called the weighted mean. Where some of the data contributes more to the mean than some of the other data. So like in the pre-calc example, your tests contribute more to your final mark than your final exam does. So how do we find the weighted mean? And this would be a formula you would get. And I'm going to use a little fancy notation. Emma, you might recognize this. Okay, X represents the individual data value. Individual data value. W represents the weight of each item or category. So what I mean by that is when we did the pre-calc example, there were two categories, your tests and your final exam. And this fancy symbol, it's a Greek symbol for finding the sum. So what you do is you take the data value times its weight in one category. And then if there's another category, you take its data value times its weight. And if there's another category, you do that. And you keep doing that until you've got all the categories. And then this just means you add them all up. This is simple. And then you take the weights of all the categories and add them all up. And then you divide the numerator by the denominator. This will make more sense when we do a couple of examples. So here's a couple of examples. So here we have another one. You want to determine your final mark in a course. This course has three categories of assessment. You've got assignments, and they're worth 75%. There's a midterm exam, it's worth 12.5%, and the final exam is also worth 12.5%. So the items are the categories. Your assignments, your midterm, and your final. And the marks you got on each one. So let's say you did several assignments, they were averaged out. Your mark was 76. That's why it says a mean of 76. You scored 68 on the midterm, and you scored 80 on the final. Now, normally when we talk about percentages, we put them in decimal form. You don't have to, it'll still work when you use the formula, but I'm going to put it in decimal. So 75% is 0.75. 12.5% is 0.125. And another 12.5% is 0.125. So to find the weighted mean, and this is a weighted mean because you got different categories that have different weights. So the weighted mean follow the formula. Your data value on the assignments is 76 times its weight, 0.75. Your data value or mark on the midterm, 68 times its weight, 0.125. And your final mark, 80 times its weight, 80 times 0.125. And remember, it says we sum them, so we add them all up. And we divide by the weight, the sum of the weights. So we add these three in. 0.75 plus 0.125 plus 0.125. Now, like I said, you could have kept them in percent form. Like you could have kept it as 75, 12.5, 12.5, but then you would have to remember to put those here. It'll still give you the same answer. So, like I said, you don't necessarily have to convert them to decimals. So when you multiply these three, add them all up, we are going to get 75.5. And when you add all the decimals up on the bottom, you get 1. So that means your final mark will be 75.5%. Okay. Second example. And this is often used too in when calculating marks. Like, let's say, well, it would be Ms. Wilkes' grade 11 advanced class and my grade 12 pre-calc class, because those are all the students taking pre-calc, grade 12 pre-calc. So we wanted to find the average of all the students that took pre-calc. Okay. We can't just add my average and her average and divide by 2 if we have different number of students in our class. Okay. If there's a different number of students, that means the weighting for each class is different. So we have to account for that. So here's a similar example. You've got 2 grade 12 English classes, and we want to find the mean final exam score. Remember, mean is average. First class has 24 students, and its mean final exam score was 62. Second class had 30 students, and its mean final exam score was 78. What was the mean final exam score for both classes combined? So we've got 2 categories here, class 1 and class 2. What's the data value for each? It's the average for each class. So the first class had an average of 62. The second class had an average of 78. But the weights are going to be different because there's more students in one class than there are in the other. So there's only 24 students in class 1, whereas there are 30 students. Back it up again. Where there are 30 students in class 2. So that means that this class carries more weight because there's more students. So one would think if you just add those 2 up and divide by 2, you get 70. Okay, but that's not right because this class carries more weight, and because the class with the higher average carries more weight, that weighted mean will be higher than 70. If this class was bigger, then it would be lower than 7. Well, let's find out what it is. So the weighted mean, again, you're just using the formula. It's going to be data value times weight of the first class plus data value times weight of the second class plus the sum of, divided by 24 plus 30, the sum of both classes, number of students. So when you do that, you're going to get 3,828 divided by 54, and that's going to be approximately 70.89%. Which makes sense because it should be higher than just averaging the 2 classes. It's not much higher. Okay? If there were even more students in this class, this would go even higher. So really, it's just a matter of recognizing when you have to do weighted mean and applying the formula. Unless it specifically says, do one or two. Yeah. So where do we use the weighted mean? Well, basically when we see the, in the last examples. So when each individual data value represents multiple people, so that's from the example we just did. That mean of 68 didn't represent one person, it represented 24 people. When one sample over-represents, when a sample over-represents or under-represents a certain part of the population, and you want to balance it out. So here you see an example, okay? You conduct a survey of Winnipeggers, but you accidentally survey more males than females, okay? The weighted mean helps you correct it. If some of the categories in your weighting are less accurate, okay, they may be given a lower weighting. And this one, and then we're going to see this in the next example, okay, it's faster than calculating the mean. So here, we've got 50 students that are taking grade 12 essential. They were asked how many hours they spent studying for an exam. 20 students said they spent 6 hours studying, 13 students said 4, 9 students said 2 hours studying, and 8 students said they spent no time studying at all. Calculate the mean. Well, imagine if we had to, without the weighted mean, what you would have to do is you would have to add 50 numbers and divide by 50. So you would have to add, like 20 students said that they spent 6, so you'd have to go 6 plus 6 plus 6 plus 6, 20 times. And then you'd have to go 4 plus 4 plus 4 plus 4, 13 times. And then 2 plus 2 plus 2, 9 times. And then 0 plus 0 plus, well, you don't really need to put those in. Okay? That's a lot of data. Instead, let's do this. So, what have we got here? We've got 0 time study, 2, 4, no, sorry, 0. Yeah, 2, 4, 6. So what's the value of each? 0, 2, 4, 6. We've got 4 categories. The value of each category is 0, 2, 4, 6. What's the weight? This is the number of students in each category. So 8 here, 9 here, 13 here, and 20 here. So instead of adding 50 numbers together and dividing by 50, I just need to add 4 numbers when I get them. So the mean would be 0 times 8 plus 2 times 9 plus 4 times 13 plus 6 times 20. And then I have to divide by the sum of the weights. So divided by 8 plus 9 plus 13 plus 20. That's a lot quicker than adding 50 numbers and dividing by 50. We did a similar example to this when we did that restaurant average example in 5.1, where we did average salary of servers, hosts, cooks. So when we do this, we get 190 divided by 50. Plus 3.8 hours. And the final example, well, I've talked about this in statistics before. One can always use statistics to present a point of view that they want, even though it may not be mathematically accurate. So here we have a chart. The percentage of people from Manitoba and Quebec who speak English at home or French at home. So one said, what they did is they said, okay, 48.64% of all people from Manitoba and Quebec speak English. Okay? And how did they get to 48? They added these two and divided by 2. Okay? What's wrong with that? More people live in Quebec. Okay? So this would probably be too high. If they have the same population, you could add these 2 and divide 2. But because Quebec has a lot more people, like 7 times as many people, okay, that's going to distort this number and not make it accurate. So no, because more people live in Quebec. So we need the populations if we want a better representation of the average. So in 2006, these are the populations of both provinces. Little over 1.1 million in Manitoba, almost 7.5 million in Quebec. Okay. Now we want to calculate the weighted mean of people who speak English at home in Manitoba and Quebec. So the weighted mean is we have to take the data value for each province. So that means the average for Manitoba, which is what? 87.27 times 7.27 times the population of Manitoba. 1,133,515. Then we have to take the data value from Quebec, which is the mean, 10.01, times the population of Quebec, 7,435,905. And then we add those together. Remember, the 87.27 and the 10.01 are the data values. The populations are the weights. So therefore, the denominator is the sum of the weights. In other words, the sum of the 2 populations. So we get this. In those calculations, we're going to get 173,355,263.1 divided by 8,569,420. And that's going to get you approximately 22.2%. That is likely or probably a better representation of the average of English speakers at home. Okay? Because even though the average of number of English speakers in Quebec is much smaller, it carries more weight because there's way more people. but it shouldn't carry so much weight that you would just average the two means. So how might the media use statistics? Well, it depends on what you want to portray to the public. If you want to portray to the public that there are a lot of English speakers at home in Quebec and Manitoba, you use that first one, you average the two means. Okay. If you want to portray that it's lower, you use this value. But in terms of what actually would be more correct, this value would be more correct. But you can see how you can calculate things different ways and use it to present a certain point of view. So if the media wanted to portray that many people in Quebec and Manitoba spoke English, they would use .6 orders. Remember, average and mean are interchangeable words. Okay. So really, a couple of things that you should get from this lesson is number one, how to calculate a weighted mean given the situation. Obviously, that's the big one. But you could also be asked, how something could be distorted and which would be a better representation measure.